Welcome back, geometry students. Mrs. Fallon here. We are on the last section of this this unit, which is 9.7. We're going to talk about something called law of sines, law of cosines. So I'm on page 274 of your student journals. So here's what I need you to really understand about law of sines and law of cosines, is we only use these for non-right triangles. So I'm going to write that down. Only for non-right triangles. And so why I wanted to stress that is because we already have strategies for right triangles, right? We already know what we can do to kind of help solve for sides and angles for right triangles. So we have the whole SOHCAHTOA, and that's sine, cosine, and tangent. And so we use this for right triangles, right? And then we have something called law of sines and law of cosines, and we use those for non-right triangles. So for the law of sines, if you looked it up, you would probably see something like this. It's a bunch of ratios. And so it would look like this, where it's sine of A over A equals sine of B over B equals sine of C over C. And so what the theory here is that there's a relationship between the sine of an angle and its corresponding side. And so what we're going to do is we're going to set up a proportion using only two of these relationships. So generally what I like to do is I like to just kind of think of it as a proportion. So I think of like sine of some angle over its side equals sine of some angle over its side. Don't get hung up in the fact that this has to be A and this has to be B. A and B are just standing for any angle and any side length in a triangle. So whether A stands for angle A or whether it stands for angle X doesn't really matter. What it needs to be true is that this angle, so notice how these are all capital letters. Those capital letters represent angles. So the sine of whatever angle this is here, this is its corresponding side. So this is the side that's across. So notice how we use sides, we use lowercase letters. So A, B, and C. And then the law of cosines looks something like this. And this is a little uglier looking formula, but we'll walk through it. So it's c squared equals a squared plus b squared minus 2ab cosine of c. So I'm not going to make you memorize these just yet. To be honest with you, you probably will eventually just kind of commit into memory because these are ones that you're going to be using multiple times. So what I wanted to remind you is that we only use these for non-right triangles. I don't want to see you using law of sines, law of cosines when you have a right triangle. There's too many complications that come up, too many errors, and so we stick with like the SOHCAHTOA trig ratios when we talk about right triangles, and then we get into non-right triangles. We expand our horizons here and talk about law of sines and law of cosines. Okay, so with that comes, and I don't know if you guys have learned a lot about like areas of triangles. There's not just one formula for the area of a triangle. So the one you probably know is area equals 1/2 base times height, right? So this works out well if you're given like a right triangle, for example, because you know the base and you know the height. Or if you're given an equilateral triangle where you're given the height. But imagine that you're given a triangle where you only are given 3 sides, or you're given an angle and a couple sides. So again, we're thinking of this in more of a trigonometric kind of way. So there's another formula for area of a triangle. Okay, so what I'm going to have you do here is, just because I think it's confusing to have all 3 of these versions, we're going to focus on only one version for this area of a triangle. And again, we already have this one, right? And there's a few others that actually I can show you eventually, but this is our kind of our basic one that we learned in middle school or somewhere along the line. But this is the area of the next one. So it's area equals 1/2 A times B sine of C. So here's what you need to know about this. And again, they give you 3 different versions based off of where A and B and all that kind of good stuff is. So here's what I need you to know about this. And I'm going to try to simplify this for you. A and B are side lengths. Okay, so again, you can notice that by the fact that they are lowercase letters. This is an angle because it's an uppercase letter, so it's a capital letter. So what I want you to understand here is that these are 2 sides and an angle. This has to be a side angle side relationship, which means this angle has to be between the 2 sides. So we use this formula when we're provided a side angle side relationship. Let me give you an example. So This is for a non-right triangle. Again, when we have a right triangle, we would just use 1/2 base times height, right? Because that would be the easiest option. So let's say I have an obtuse triangle. So this is 110 degrees. And I'm going to call this, I'm going to label this something other than A, B, and C, just so that we don't get confused. Okay, so 12 and 15. Notice my scenario here. I have side, angle, side. So given this problem, given this type of relationship, we can use this formula for area as opposed to this formula. It's just much easier. If you had to use this formula, you would have to first figure out the height, and then, kind of go from there, which, given the information, may not be easy to do. All right, so for this one, what we're gonna do, and again, if you have a side-angle side relationship, it's actually pretty straightforward, but here's how you would use it. So 1/2 AB sine of C. A and B, those lowercase a and B are your two sides. Again, I don't care if it's marked as A, if it's marked as Q, if it's marked as C, I don't really care. This just means two sides and the angle in between them. That's what I want you to understand about this. This means two sides and the angle in between them. I don't care what the letters are attached to them. So the two sides I'm given are 12 and 15, and the angle in between them is 110 degrees. So that's literally all you're doing. And so, to be honest with you, this is pretty straightforward. All you're gonna do is you're gonna grab your calculator. You're gonna make sure you're in your degree mode, which I think everyone is as of right now. You're gonna do 1/2 or 0.5 times 12 times 15, and then just hit sine of 110. And that's it. And you get an area of 84.57 units squared. So the area is 84.57 units squared. So this formula comes in handy when you're not dealing with a right triangle. So again, if you're dealing with a right triangle, stick with your basic 1/2 base times height. But if you're dealing with a non-right triangle, this is gonna be an easier formula for you to kind of deal with area. All right, let's go on to page 275. So this is kind of getting more into how we're going to use law of sines and law of cosines. So rather than just the area. So let me go over a couple examples of what it means. So this is your proportion, right? And so whether you do sine of A over the sine of the angle over the side, or whether you do the side over the sine of the angle, just like any other proportion, it doesn't really matter. Let me give you an example of how we're going to see this, and so that way you can kind of use that to kind of help you understand this a little bit better. So a lot of times we use law of sines, law of cosines, excuse me, in a scenario where we're asked to solve a triangle. All right, so I'm just going to draw a triangle. It's obviously not to scale, so, I'm going to call it R, P, and Q, and I'm going to give you, 70. I'm going to give you 36, and I'm going to give you 18. And so my directions will say something like solve the triangle. So first and foremost, to solve the triangle, think about what you need to find. So remember, solving a triangle means find all the missing side lengths and missing angles. So this is side P. This is angle R and angle P. So on the side here, I'm going to write measure of angle R, measure of angle P. Please organize your work, because if we have, as your teacher, have to kind of like go hunting for it, that generally doesn't mean well for you. Side length be side P, and so those are the three pieces of information we're using. All right, so let's use law of sines to help figure this out. So what we're gonna do is we're gonna pick, so again, I kind of look at law of sines as just being like this relationship here, sine of A over A, sine of B over B. I kind of ignore the third one because you only need two of the ratios to be able to set up that proportion. And so again, what this means is sine of an angle over its corresponding side equals sine of an angle over its corresponding side. So ultimately what you're doing here is anytime, and this is how you know when you're going to use law of sines, anytime you're given an angle and a side across from it in a non-right triangle, if you're given an angle and a side across from it, so notice what I have here, an angle and a side across, I can set up law of sines. So how it would look at this, sine of my angle over the side across from it. So now what I can do is now I can solve for any of the other pieces of the puzzle. So think about what you have given to you. So in here, I'm given that PQ is 18. So I'm given a side length. So I'm going to put that down here because that matches the side length. It matches, or this kind of corresponds with angle R. So I'm going to say sine of r. So again, you're setting up a proportion where you're going to know 3 pieces of the puzzle and you're solving for that 4th piece. That's it. So how I knew to use law of sines is I was given an angle and a side across from it. And then, well, I said, well, since I was given side 18, I knew that angle r was across from it, so that's what I'm solving for. The rest is just cross multiplying. So you're getting 36 times sine of r equals, and then just do this in your calculator, sine of 70. So I'm going to do sine of 70, close your parenthesis, times 18. Leave your answer in your calculator. You don't want to round. I'm just going to round on my paper because I just don't want to write all those decimals. Now we're solving for r. So let's divide both sides by 36. So again, this is where I did not leave it out of my calculator, so I'm just going to hit divide 36. So I get this big long number. Again, keep it in your calculator. Don't, round it on my paper, but don't go ahead and round it on your calculator. All right, so now we're solving for an angle. Do you remember how to solve an angle? We talked about that in the last section. So anytime you're solving for an angle, you're going to use inverse trig. So that is the one where we're going to use sine to the -1 of our side length, which in this case is about 0.47, and it's going to equal our angle. So on my calculator, what you're going to do is you already have that kind of number in here. You're going to hit second sine, and then I want you to bring up the previous answer, so you don't have to type all those decimals in. So to do that, you're going to hit second, and then the answer button, which is down here underneath the negative sign. So second negative sign. So see how it goes, inverse sine of previous answers, what that means. All right, let's round our angle to the nearest whole number. So round it to 28 degrees. So I'm going to write down here 28 degrees for angle R. I'm even going to put that in my diagram here so that I have that piece of the puzzle figured out. All right, let's do some more. Probably angle P is probably the next easiest one to find, right? So if we know with the triangle sum theorem that all 3 angles have to add up to 180, so let's do 180 minus 70 minus 28 at 82. You don't really have to show work for that one because it's just subtraction. We all know you guys can do subtraction. And then last but not least, we're solving for side P, it looks like. So you're going to do another ratio with law of sines. So again, pick a side and angle that you already know. So let's use the one that we already started with. So sine of 70 over 36. So you always want to start with a side and angle that you know. So we were given this angle, given that side. If we're solving for P, right? If we're solving for P, then we have to use the ratio of side P and angle P. So this time I'm going to do sine of 82, because 82 is angle P, over side P. This time we're solving for a side as opposed to solving for an angle. Same method, but let's cross multiply. So P times sine of 70 equals, and then let's do this in our calculator, sine of 82 times 36. Again, just round it on your paper, but don't round it on your calculator. So like I have it like this, right? I'm going to divide both sides by sine of 70. So I'm just going to hit division, sine 70, and this is what I get for an answer. Let's take this now that we're done. Let's go ahead and round it to 2 decimal places, so I get 37.94. And that's it. So this was this is kind of what we're going to be, the bulk of what we're going to be doing. So this ended up law of sines. We did law of sines twice. So again, notice this was a non-right triangle. The only way we need to use law of sines is if we're given an angle and a side across from it. That's how you know you're going to use law of sines. Let's use law of cosines. So law of cosines is for when you don't have an angle and a side across from it. So let's say you have a scenario, and a lot of times this comes into play as if you have side angle side or side side side. Okay, so there's 2 scenarios when it comes to law of cosines. So this is generally that we use. And in those cases, we won't have an angle and a side across from it, which is why we end up using law of cosines. So let me give you an example. So I'm going to give you another triangle here. Okay, we'll call it A, B, and C, but again, the letters don't really mean anything. So I'm going to go, this is C and 40 and 20 and 25. All right, so what I'm missing out of this one is I'm missing side C, I'm missing the measure of angle A, the measure of angle B, and side C. So again, organize your work on the side so that we can, grade it easier, but also so that it doesn't get, lost in your work. All right, we are asking, I'm gonna go ahead and have you solve this triangle again. So notice I have an angle, but I don't have that across from it. Notice I have a side, but I don't have an angle. Side, no angle. This is how you know you can't use law of sines, because you're not given a side angle relationship, okay? So we can't use law of sines, great. So let's use that other weird looking formula. So they're gonna give you all three if you look in a textbook. I always just use this one. And again, it's because they're kind of showing you that, oh, well, if you have A and B and then versus C, again, just remember that A, B, and C are standing for, lowercase a, B, and C stand for sides, capital letters stand for angles. What you have to be careful for with the law of cosines is that this, so you see how this says cosine of C, that's the angle, and this said side C? What you have to remember with law of cosines is this angle and this side have to be across from each other. So let's start with this formula. So C squared equals A squared plus B squared minus 2AB cosine of C. So if I'm given a side length, and I'm given, well, I'm given an angle, right? So I'm given only one angle in this triangle, which is I'm given this angle 40, which means this side has to be the one I'm solving for. So whatever this angle is, this is the side across from it. So I'm solving for C, it matches up with the letters this time. A and B are just your other two sides, so it really doesn't matter if you put, 25 or 20 in either order. 20 and 25, and then cosine of C, which is 40 degrees. Okay, so all I did here is I entered in all of my information. So the angle here has to match this side. So this is angle 40 degrees, this is the side that's across from 40 degrees. Everything else is whatever else we have in our problem. So we have two sides, and that's all we're putting in here. What I encourage you to do is you can do this. So since we're solving for, you can do all of this in one step in your calculator. I encourage you to do that. So let me show you how that looks. So I'm going to clear this out of here. So we're going to do 25 squared, hit the squared button over here. It's right over here, down here, kind of diagonal for number 7. 25 squared plus 20 squared minus 2 times 20 times 25 times cosine of 40. So again, I just did the entire problem, that whole thing in one step. So I encourage you to do that so that we don't mess up. Okay, leave your answer in your calculator, but round it on your paper. So I have 258.96-ish. This is an important step because we want to make sure that, we want to see all the numbers plugged into your calculator or into your problem correctly. We want to see that you've kind of come to this step. This is not side C though. Remember, this is C squared. So you need to do one last thing and square root both sides. So square root and then hit second answer to bring up all of that previous answer so that you're as accurate as possible. So now we're going to round it to side length, so that's rounded 2 decimal places. So 16.09. All right, 16.09. I'm going to go ahead and write that on my diagram as well. Fantastic. I've solved for a side. Fantastic. All right, now you might notice we have to solve for 2 angles. Okay. Do you notice now that we have a side angle relationship? Most people find law of sines easier to deal with than law of cosines. So now I can go ahead and use my law of sines, because I'm given this the relationship here, to either solve for angle A or angle B. Doesn't really matter. So I'm going to go ahead and set up law of sines. So I'm going to do sine of 40 degrees over 16.09, because that was what I figured out for side C, equals, now you get to choose here. Do you want to solve for angle A or angle B? Well, let's do it alphabetically, right? Let's do angle A. So this would be sine of angle A over side A, which is 20. Alrighty, so then let's go ahead and cross multiply. So I get sine of A times 16.09 equals, and then put this in your calculator, sine of 40 times 20. Again, don't leave the decimal in your calculator. I'm just going to round it on my paper. Get 12.86. And then I'm going to divide both sides by 16.09. So I get sine of A to equal about 0.80. Again, please don't round. It makes, if you want to get the same answers, accuracy does count. All right, so now what are we doing here? We're solving for an angle. So remember, to solve for an angle, you have to do the inverse of about 0.8. So again, you're just going to use the exact value. So you're going to do second sine, so second sine brings up the inverse of second answer. So bring up that previous answer, so all those decimals. And I get about 53 degrees. So I figured out that angle A is 53 degrees. Well, now you know angle A is 53. There's not a whole lot of work you have to do for angle B, right? So just take 80, subtract 53, and then subtract 40, and you have 87 degrees left over for angle B. And that's it. So that's how we're using law of cosines. I'm going to give you one more example, and this one is a bonus. So if you want to grab a sheet of paper for me, I wanted to go over a law of sine. So that was like kind of a side angle side relationship. I want to go over one where it's side, 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 just because it's a little bit different, and I want to make sure that you have some information on that. So let me show you an example. So this is a scenario where you're given a non-right triangle. Let's go A, B, C. And you're given all three side lengths. So this is a side, side, side relationship. We can still solve this triangle. We cannot use law of sines because we don't have any angles and we don't have that angle side relationship. So my goal here is to find the measure of every angle. Measure of angle A, measure of angle B, measure of angle C. All right, so what I need you to always do first on this one, okay, so this is like a little kind of rule. You want to find the largest angle first. And the reason why is because we got to figure out if there's an obtuse angle in this triangle. Because otherwise, if you do it in the wrong order, like you find an acute angle first, we've kind of already determined kind of what the other angles have to be. And so because we don't know if there's an obtuse angle here, we have to try to solve for it first to see if it's obtuse. So what I mean by that is, if we were given three sides, which of these angles has to be the largest angle? Well, the largest angle has to be across from the largest side. So if this is side 30 degrees and this is angle A, then angle A has to be the first angle I'm going to solve for. All right, so let's write down our formula. So A squared plus C squared equals A squared plus B squared minus 2AB cosine of C. So you may learn another formula where they rewrite it, so it would look like this. Cosine of C equals A squared plus B squared minus C squared over 2AB. You might see this equation, and that's okay. I don't like to use this one as much, especially for anybody who's in, like, wants a challenge, because then when you have to memorize another formula, and I want you to be able to manipulate this one more so. So I just pointed out here that this exists, so if you ever look it up online, or maybe a friend or somebody who's helping you out or something might kind of give you that formula, that's where that's coming from. All they're doing here is just solving this equation for cosine of C. But so I'm just going to kind of put that on the side there. It exists, but I'm not actually going to use it. All right, so because we're going to solve for angle A, so that's angle A, this has to be side A. So again, I ignore the fact that A, B, and C. I don't care what letters we use. So again, it doesn't correspond to these A, B, and C's. So all I have to make sure is the angle we're solving for, and this is the side across from it. The other two sides go in here. So 27 and 18, doesn't matter which order. Okay, gotta squeeze it in there. All right, here's what I would do in order for you not to get, order of operations incorrect. So I would start by doing 30 squared, which of course is 900. Because there's a minus sign here, do all of this, kind of this first part, and then do the second part. So here's what I mean by that. There's a mistake that a lot of people make, and they just do all of this in one step, and that's not following order of operations. So do this in two chunks. So 27 squared plus 18 squared. So 27 squared plus 18 squared, and I get 1,053 minus, and then you can do all of these numbers here times cosine of A. So 2 times 27 times 18 is 972 cosine of A. So do you understand why you can't do these two things together? So that's why it's wrong to put like all of this together, because you can't do subtraction before you do multiplication. And so that's generally the largest or the biggest mistake I see. All right, so again, follow order operations. If you have, in order to solve this, I would have to subtract 1,053 from both sides, right? So to get that to go away. So 900 minus 1,053, and I get negative 153 equals negative 972 cosine of A. Divide both sides by negative 972. So divide by negative 972. I get, again, I'm going to have this decimal in here, so I'm just going to kind of round it, but I get 0.157 cosine of A. Remember what you're doing here. You are solving for an angle. So you're going to use inverse cosine of 0.157-ish. Again, it's in my calculator to solve for my angle. So I'm going to do inverse cosine this time of second answer. And I get angle A to be about, if we round to the nearest whole number, which I like to for angles, is 81 degrees. Mark it on my diagram. Okay, so that was probably the hardest part, right? The rest is going to be fairly straightforward. Now that we have an angle and a side across from it, we can set up law of sines. So I can do sine of 81 over 30, because I'm given that angle side. And then you pick. It doesn't matter now that we've solved the largest angle, which is not obtuse, by the way. It doesn't matter if you want to solve for angle B or angle C. So I'll just go with B. So sine of B over 27. So this is the ratio I'm setting up. I'm going to cross multiply. So 30 times sine of B equals sine of 81 times 27 is about 26.67. Again, don't round. Take that number and let's divide it by 30. So I get about 0.89. And then because we're solving for an angle, we're going to do the inverse. So second sine of second answer, and I get, if we round to the nearest whole number, I get angle B to be 63 degrees. Okay. Now that we know angle B is 63 degrees, there's really not a whole lot of work to do for angle C. So 180 minus 81 minus 63 means there's 36 degrees left over for angle C. So that's how you would have to solve for side, side, side. So again, the caveat here is that you have to solve for that largest angle first to determine if there's any obtuse angles in your diagram. And in our case, there wasn't, so it was okay. All right, let's keep going. I got a little bit more to do. So there's some extra practice that I'd like to look at. And it is on page, let's see here, it's 276. Which is just kind of on the back of one of the last page here. All right. So a lot of this is pretty straightforward. They're just asking you in the first ones is to use your calculator to find the trig ratio. In other words, can you put this in your calculator? So again, make sure you're in a degree mode. So what I'm asking you to do here is sine of 225. You would get that answer. So they're literally just asking you to plug this into your calculator. And it says to 4 decimal places, so we'll round to 4 decimal places. I'm not going to bother going over 2 and 3. You can go ahead and do that on your own. But again, you're just plugging that into your calculator. Find the area. So notice this is side angle side, side angle side. So again, remember the area formula was 1/2 AB sine of C. So A and B stand for your sides. C stands for the angle in between them. So you would do 1/2 of 14 times 9, sine of 79. Okay. And then I would do, so 0.5 times 14 times 9 times sine of 79. In my calculator, I get 61.8. Does it ask you, it says to round to the nearest 10. 61.8. Doesn't give me units, but it is area, so we should use area squared, which is unit squared, I mean. All right, so I'm not going to do number 5. You can do that one on your own. And then the bottom here says, solve the triangle, round your answers to the nearest 10th. So this is one where you would have to, do what we just did in terms of solving for all of our side lengths, solving for all of our angles. So I will do one of these again just to kind of give you an idea. Here's one so notice that you have a side angle relationship here. You have a side angle relationship here. So I can use law of sines to start on those two. Notice this is that side, 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 so I have to use law of cosines. So since we just did an example like this, I'm going to have you guys try one on your own. I'll just do number 6, and then we'll kind of go from there. So again, I am solving for side A, side C. So I'm going to put down the measure of angle C is what I'm looking for. Side A and side C. Now they don't give you a whole lot of room over here, so feel free to do this on a separate sheet of paper. Probably the easiest thing to find first is to find that missing angle, right? So you're just subtracting 50 and 30. And you get 100 degrees. So I'm going to do measure of angle C is 100 degrees. Okay. You have an angle and a side relationship, right? So you have 22 and you have 30. So I'm going to do sine of 30 over 22. And then I'm going to pick either side A or side C to solve for. So if I want side A, I'm going to do sine of 50 over side A, since those are the two that are across from each other. Cross multiply, so A times sine of 30 equals 22 times sine of 50. And I get about 16.85. I'm going to go ahead and divide by sine of 30. And you get 33.71. It actually asks you to run to the nearest tenth, so we'll say 33.7. So 33.7. And then we have to do one more kind of calculation to figure out side C. So I'm going to start with sine of 30 over 22 again, and then do sine of 100 over C. And I'm going to cross multiply. So 22 times sine of 100, I get about 21.67, and then divide both sides by sine of 30, and I get 43.3. All right, I would strongly encourage you to try the rest of those. And then what I'm going to do right here, I would like you to pause the video, try these, and let's see if you get the right answers. All right, so hopefully you've tried these. Let's see if you got the right answer. So if you've done all of them, I'm just going to give you the answers for all the ones that were missing. So I got negative 0.3584. I got negative 9.5144 for number 3. For number 5, I got an area of 85.0 units squared. For number 7, again, there's hardly any room down here, but for number 7, you were missing the measure of angle B, the measure of angle C, and side C. All right, so I got these to be 39.3 degrees. For C, I have 58.7 degrees, and for side C, 21.6. And then for number 8, you were missing all 3 angles. So the measure of angle A, the measure of angle B, and the measure of angle C. And so for all of those, I got for angle A, I got 38.2 degrees. Measure of angle B, I have 120 degrees, and measure of angle C, I have 21.8 degrees. Whoops, I'm sorry. I didn't have my camera up in there. All right, so those are all the angles that we have for angles and sides that we're missing for 7 and 8. So what I would do is if you didn't get those right answers, try them again. And if you still can't figure it out, let's either handle it in class or handle it in Black Hawk Hour. So you want to make sure that you're good at this and be able to get the right answers. That's ultimately the goal. All right, that's it for now. Hope you have a good rest of your day. I'll talk to you later. Bye.